Good evening, students. Today we are going to see memoryless property of geometric distribution and some problems based on geometric distribution. Memoryless property. This is an interesting property. Actually, only one discrete distribution, geometric distribution, and in continuous case, exponential distribution only satisfy this property. Okay, memoryless property. First, we can see its statement. If capital X has a geometric distribution, then for any two positive integers m and n, probability of x greater than m plus n given x greater than m is equal to probability of x greater than m. Now we can see its proof. Proof also very interesting. Actually, what we know the probability of A given B, the conditional probability is nothing but P of A intersection B by P of B, provided P of B not equal to 0. When we use this definition in our given probability, we can write it as P of x greater than m plus n given x greater than m equal to P of x greater than m plus n intersection x greater than m by P of x greater than m. We know that already we told very clearly m and n are any two positive integers. So when we take the value m here and here it is m plus n, m plus n greater than values and x it takes greater than m. So what actually comes as the common portion for this two intervals, which is easily identified that p of x greater than m plus n by p of x greater than m. Now we can write for any k P of x greater than k. What it happens by means of geometric, we can see summation x equal to k plus 1 to infinity. Actually, it goes till infinity, We can write its formula q power x minus 1 p. That is equal to, when you substitute x equal to k plus 1, q power k p plus q power k plus 1 p plus etc. It goes. This is again a infinite series, binomial expansion. When we use the formula here, we can get it as p of x greater than k is nothing but q power k p is commonly taken outside 1 plus q p already we have taken out. So q plus q square plus etc. It goes like this. That is equal to q power k p into 1 minus q whole power minus 1. This is nothing but p. So q power k, p by p and p are cancelled, q power k. Now you write your required left hand side p of x greater than m plus n given x greater than m equal to what we derived already, p of x greater than m plus n by p of x greater than m. So for the numerator, we can write it as q power m plus n, replace k by m plus n. In the denominator, q power m. Now we get it as q power n, which is nothing but probability of x greater than n, which is our required right hand side. Therefore, left hand side equal to right hand side. The memoryless property is proved. That's it. Is this clear? You understood the memoryless property and its proof? Now we can go to the problem. How many problems we can able to do within the period? We can do all the problems. I'll start with problems. First problem. Everybody please write down the question. If the probability that an applicant for a driver's license driver's license will pass the road test on any given trial is 0.8. What is the probability that he will finally pass the test first subdivision on the fourth trial second subdivision in less than 4 trials? Here, taking x is very important as I told previously. Let x be the first success. First success after x minus 1 failures. Then p equal to 0.8, so q equal to 1 minus p equal to 0.2. By geometric distribution, p of x equal to x equal to pq power x minus 1, x equal to 1, 2, 3, etc. infinity. When we use this formula, actually what we have to find? To find P of on x trial, P of x equal to 4. Second subdivision, this is first subdivision. P of x less than 4. Now we can start P of x equal to 4 equal to 0.8 P 0.22 to the power 4 minus 1. So 0 0.8 into 0 0.2 to the power 3 equal to 0.0064. Similarly, P of x less than 4 trials, that is equal to, so here x takes the values 1 to infinity. When x, P of x equal to 1, 2, 3. So all three values, x less than 3 is not included, 1, 2 and 3. You just find it as, I give it as a home. Okay, everybody try to get its answer. Shall we go to one more problem? Yes, we can go to one another problem. Second question. A trainee soldier shoots a target in an independent fashion. If the probability that the target shot on any shot as 0.8. By means of this given idea, we have to find this. What is the probability that the target could be could be first hit at the sixth attempt? Second subdivision, what is the probability that it takes less than 5 shots? These two subdivisions we have to find. First we can fix what it is x. Let capital X be the first success after x minus 1 failures. Then P is given as 0.8, Q is 1 minus P, so that it should be 0.2. Now, by using geometric distribution, by using Geometric distribution P of x equal to x, that is equal to q power x minus 1. X takes the values 1, 2, 3, etc. What we have to find? To find P of x equal to 6 and P of x less than 5. Dear students, I write down the final answer on board. You try to get its answer whether it comes as correctly or not after doing yourself by substituting x values in both the cases. P of x less than 5 answer is 0.8. See, all of you try to get these answers correctly. Next class, we can see the continuous kind of distributions. Thank you, students. Thank you. All the best.